Hello everyone, my name is Haoyu Niu. My project is design a power amplifier to control rotation of a servo motor. Servo motors are widely applied in the devices like radio-controlled airplanes, elevators, and robotics. The purpose of this project is designing a 555 oscillator circuit to control the two servo motors so that it can control the movements of the finger of the prosthetic hand. The servo motor has a small body, high torque characters, which is controlled by the received pulse-wise modulation. The first part of the experiment was to test the parameters of the servo motor by controlling the duty cycle of a square waveform. As we can see, the duty cycle is from 2% to 12%, and they also have the corresponding rotation angles. Step 2. Implement the duty cycle of a square wave using a 555 timer. When the voltage of pin 2 drops to one-third of VCC, the pin 3 will be output the high signal. In addition, when the voltage of the pin 6 increases to 2/3 of the VCC, the pin 3 will be output the low signal. Back to this formula, we can know that we have a certain value, the period, which is the 20 milliseconds, and the C1 is 1 microfarad, and the constant value, the 0.6093. We can know that the R1 plus the 2 times R2 must be a constant. Step 3, I separate the total value of the R1 plus 2 times R2 is 2176 kilo ohm. So the R1 R2 comes to 880 ohm, and R3 potentiometer is 20K, which is used to adjust the PMW of the oscillator and also used as the rotation controller of the servo motor. Step 4, to create a simulated circuit as we can see here by using the multisim. This two image shows the minimum control of the servo motor. When the value of the potentiometer is 0 ohm, the period is around 20 milliseconds, and the duty cycle, which is the 4.67%, and the PMW is the 946 microsecond. Simo as the maximum control of the servo motor. The part 5 is to create a prosthetic hand to test the project. The test result shows that the efficient duty cycle is from the 4.67% to 12.15%, but for the lab condition limits, the physical circuit cannot work well and had to be troubleshot properly. As the multisim circuit was a simulator, the simulated circuits run at zero without taking into the account the equipment and environmental interference which could have altered the result of the research project. I gratefully acknowledge the support from the CUNY Research Scholars Program. Many thanks to Professor Huixin Wu for inviting me to participate in this research experience. Thank you.